This is not very new. For this unit, we're going to find domain and range of several different relations, and then from there identify whether or not those relations are in fact functions. All right, so you'll see this worksheet, and I've attached it. So if we are looking at these graphs, and one thing I do want you to identify, because it doesn't say on here, if no increments are written, it's understood that we're working in increments of 1. Okay, so every little tick mark is 1 unit long. So our objective here is to identify the domain and range of all of these relations. Domain, that's our input. Those are the x's. So we want to see what the x values are that are included. Let's go from least to greatest. So let's label some of these axes. So I labeled the axes for the x's where I saw the ordered pairs. And our domain looks to be these values. Now we're going to do the same thing with the range. We're going to look for the y values. So I've labeled some of the coordinates for the y-axis, and looking at that, it seems as though our range would be the following. So if we want to see whether or not this relation is a function, we would do our vertical line test, and we would identify that right here, 2 of those ordered pairs intersect. Because for that one x value, there are 2 y values. When you look at the second graph, we want to see where the domain and range lie with them. So let's label the relevant x values. So it seems as though our line segment starts at -2 on the x and ends at 5. You'll also notice that all of the values in between -2 and 5, all of those x values are also included on our line segment. So we want to write this, you all, as our compound inequality. -2 is less than or equal to x, which is less than or equal to 5. We want to include the equals because those are closed circles, so they are included in the domain. This is telling us all of the values in between -2 and 5 inclusive. So now for our range, we want to find the relevant y values. That's our output. And so it looks like our line, the smallest y value it takes on is -4, and the biggest is 4. So we would write the range as its own compound inequality, and that would be that -4 is less than or equal to y, because we're now looking at the y values, which is less than or equal to 4. That means all of the values, the y values, in between -4 and 4, inclusive, fit our range. So to find out whether or not this is a function, again, we would take that vertical line and see, is there any place on that graph where it intersects that vertical line in one point? No. So this would be the answer to 1 and 2. Now we're on to something a little bit different with this graph, because we see that the arrow keeps going, and that implies that our graph does not have a start and an end. This continues without bound. So let's, one more time, for the domain, write the relevant x coordinates. And I think we can identify that the x values on this graph start at -5, but we can also see that they just keep on going. That arrow means keeps going and going and going. So we're looking at 10, 20, 100, 1,000, 1,000,000. All of those values would be included in our domain. So how do we write that? We would write that as just a simple inequality. No need to write it as a compound because it continues on and on. So our domain is x is greater than or equal to -5. Now let's look at the y values and see what are the y values that are relevant here. So let's label those. So we see that the smallest y value that this graph has is -3. But what we do also notice is this keeps going and it's getting a little bit bigger, slowly but steadily. So our y values, as this goes on and on, they're just gonna keep getting larger and larger. And that arrow means don't stop, don't stop. It's gonna keep going. So how would we write the range? We would say that y is greater than or equal to -3. We're including -3 and all of the y values larger than -3. And again, is this relation a function? I would look at my vertical line and it all checks out. It doesn't cross it in more than one point. Now that we have an idea of what we're looking for these, I've labeled my axes, and for the domain, I'm hoping that you are looking at the x values, and we see that the smallest x value is -1, but there's an open circle right there at -1, and the largest value that this graph has is x equals 6. So for our domain, we would once again use a compound inequality because we are saying that the domain would be the x values in between -1, but not including -1, and 6, and including 6. So we write that as -1 is less than x, which is less than or equal to 6. So that tells us immediately that we are not including -1, but that's where our boundary lies. And for the range, we can identify that the smallest value that our graph takes on is -3. And the largest y value that it takes on is 5. And they are both included. This is included, closed circle, and here it's a closed curve that hits -3. So our range for this would be -3 is less than or equal to y, which is less than or equal to 5. So a reminder, when we're talking about domain, we use x, input, range, y, output. Now, is this relation a function? So let's not bring out the vertical line and just look and pretend you have one. And I hope that you would see that that line would not cross that graph in more than one point. Looking at 5, again, we identify that those arrows mean this graph continues in both directions. So this would take on the stretch of, all of the x's. Once it keeps going, all of those x's are eventually going to be on that graph. They're going to be really small negative numbers, but they're still there nonetheless. So, folks, what do you think the domain of this function is? It's all real numbers because every x value eventually is going to be on that graph, and it will have a corresponding y value. Now let's look at the range for a bit. I think we can agree that this is the largest y value that it takes. But we can also see, because of the arrows, that this just keeps going down, down, down. It keeps including all of those small negative numbers. So we would write our range as y is less than or equal to 4. So this keeps going to -infinity. Now, if we took our vertical line and we dragged it across this graph, it would check out. It does not cross that graph in more than one point, so this relation is a function. So looking at the graph in 6, we're looking at all of the x values for the domain, and it looks like they start here. So how would we write that? We're including all of the x's that are greater than or equal to -2. Our range, however, because of those arrows, that goes on and on in the positive big direction. This one goes on and on in the negative little direction. And it continues without bound. So our range would be all real numbers. And if we took our vertical line, I'm hoping that you would see anywhere on that positive side, it's going to cross that it's going to cross that graph in more than one point. So what do we know about this relation? It's not a function.